Hello scholars, welcome back. Mr. Hinkle here, and it is my pleasure to introduce sedimentary rocks. Sedimentary rocks, so amazing. Let's define what sedimentary rocks are and then discuss the features of the 4 distinct types of sedimentary rocks. So zoom out, let's go the rock cycle, which describes the creation, the transformation, and the recycling of earth materials. There are 3 types of rocks in the rock cycle, and they are identified or classified based on how they form. Igneous rocks form by the solidification of molten material. Sedimentary rocks form from the accumulation, deposition, and lithification of sediments. Metamorphic rocks form by changing their mineralogy from either of the 3 rocks to a new kind of rock. We're focused on sedimentary rocks. So sediments are created through the process of weathering. From there, weathering will create smaller pieces of rock that is eroded, transported, and deposited. Then, through the process of lithification, compaction, and cementation will transform or create sedimentary rocks, which are wildly important because sedimentary rocks cover about 75% of the Earth's land area. They form near the surface of the Earth, and they're very rich in economic resources. Sedimentary rocks contain all of the coal, oil, and natural gas that we have available to power our modern society. Sedimentary rocks contain fossils. The study of fossils allows us to understand how species change through time or evolution. Whoa, that's a kind of a big, important topic. And then sedimentary rocks also preserve ancient environments at the time that they were formed. So what was the Earth like 500 million years ago? Good question. How would we even begin to ask that question? I know. Let's look at the rocks. Which rocks? Sedimentary rocks, because they preserve ancient environments. That is really cool. Oh, pins falling everywhere. Okay, so we are getting into sedimentary rocks. Right? Form by accumulation of sediments and offer info on Earth history. Okay, so this is basically what they are and why they are important. Cool! Okay, so you may have been driving somewhere and you go, wow, look at all those cool rock layers. Well, what you're really saying is, wow, look at those cool sedimentary layers. But you're also saying, wow, look at those cool sedimentary beds, individual layers. And when you look at them all together, wow, look at those cool sedimentary strata. Strata formed through the process of stratification. Okay, terminology, I know. Geology is like speaking another language. And I say all these words, and you're like, what the heck, another new word? Yes, and it's going to continue to happen over and over again throughout the course of these lectures. That's why I put keywords down. Sediments, sedimentary rocks, stratification, process of developing sedimentary layers. Layers are known as stratigraphic beds, individual layers, and then they form multiple layers into strata. Okay, so sedimentary beds. Lots of beds together forming sedimentary strata. This is a cool image. I really liked when I found that one. Okay. There are 4 main types of sedimentary rocks: clastic, chemical, biochemical, and organic. And the type of rock is going to reflect the depositional environment from which they formed. It's also going to reflect the processes for sediment deposition, because sedimentary rocks form by accumulation of sediment. Here's our introduction to each of the 4 types. Clastic sedimentary rocks. So, large masses of crustal rocks or bedrock will break into smaller pieces through the process of weathering. Those smaller pieces are called clasts or detritus. And we can identify these clasts based on how big they are, which is also known as grain size. When broken pieces of rock become sedimentary layers deriving primarily from the processes of physical weathering, we classify them by grain size sorting and grain shape. So rocks that are made of other types of rocks, broken down rocks, clastic sedimentary rocks. Clastic sedimentary rocks are the classic kind of sedimentary rocks that you think about when you're thinking about sedimentary rocks. Whew, that was awesome. But it's not the only type of sedimentary rock. So rocks made of broken chunks of other rocks, the chunks are called clasts, giving us clastic sedimentary rocks. Chemical weathering will dissolve through the process of dissolution and hydrolysis with carbonic acid, will dissolve ions into solution. But in certain situations, those ions that are in solution will deposit out of solution, forming what is known as chemical sedimentary rocks, because it's a chemical process. These are limestone tufa towers in Mono Lake that formed when the lake was a lot higher, and this material came up from the bottom and precipitated out of solution. When we're thinking about chemical sedimentary rocks, we're identifying the rock by the composition of the minerals that make it up. It is an accumulation of sediments. The sediments were actually dissolved into a solution. They precipitated out, which is the deposition, and transformed into rocks, which is the lithification that gave us chemical sedimentary rocks. So let's make a list here. What color should we do? Red. Clastic, chemical, maybe my favorite kind, biochemical. Organisms in the ocean, marine phytoplankton, any type of marine animal that has a shell is going to use dissolved minerals, dissolved ions in seawater to build their shells. The main mineral is calcite, but they'll also use aragonite and sometimes dolomite to build their shells. Well, their shells are made of minerals. Now, when these animals die in large proportions, their shells accumulate on the bottom of the ocean. They actually form, it's either called a siliceous ooze or a calcareous ooze. These are the scientific names. And then as the ooze deposits, it transforms, it accumulates as sediments in the bottom of the ocean, then it transforms into sedimentary rock through lithification. But the original source was once living organisms, and so we call the lithification of these types of sediments biochemical sedimentary rocks. There are chemical processes that are happening, but the chemical processes are also occurring because of the organisms that are utilizing the minerals before they deposit. Limestone, dolostone, these are examples of biochemical sedimentary rocks. The Dolomites in Italy are biochemical sedimentary rocks, and I love that because they're big mountains on land that were once at the bottom of the ocean, and it just illuminates how amazing our Earth is and how dynamic the surface of our Earth is, that it can create and transport and move rocks all over through plate tectonics. Plate tectonics is the idea that the surface of our Earth is covered by large, rigid bodies of rock that move around relative to one another, meeting at plate tectonic boundaries. This explains why we have mountains and oceans and earthquakes and volcanoes and every other feature on the surface of our Earth. Thank you, plate tectonics. Last but not least, we have organic sedimentary rocks. So organic is like it sounds. It's sedimentary rocks created from primarily organic material. There's two main rock types. We've got coal and oil shale, both sources of fossil fuels. Here we have this very dark, black, organic, rich layer. It's kind of like humus in topsoil. But when it accumulates in such large portions over time, compaction, burial, transformation, sedimentary rock. We classify, right? Name of the game, identification, classification. So we can look at sedimentary rocks and we can say are clastic or detrital sedimentary rocks, of which we described here first, are identified by grain size. We're looking at the grain size to put a sediment name on them, to give them a rock name. We can come over here to chemical, biochemical, and organic sedimentary rocks. Now we're going to use, and that's going to be this one. Let's use a different color. Now we're not necessarily looking at grain size. It can help, but it's not the determining factor. The determining factor, let's do this, grain size, is going to be the composition and the texture of the rock. Giving us a variety of different types of rocks with a variety of different names of rocks. Sedimentary rocks are one of the three main types of rocks, and they form through the accumulation of sediments that are transformed into sedimentary rocks. There's four kinds: clastic, chemical, biochemical, and organic. We identify clastic by grain size, the other three less common but also very important by composition and texture, and it is sedimentary rocks that really tell the story. And we don't leave igneous and metamorphic out, they're important too, but sedimentary rocks preserve depositional environments and they inform us on the conditions at the time of formation so that we can go back into Earth's history and understand what it was like millions of years ago. So thank you so much. This is Sedimentary